invite me. So I'm Davide. I work on Ethereum Foundation in a research team called RIG, Robust Incentives Group. We work on the mainly protocol economics mechanisms. I'll talk about Rollup Economics 2.0. So about a year ago, Barnaby from our team published a post called Understanding Rollup Economics from First Principles, where it was essentially laying like some framework, some model to understand like the value flows in rollups. But since then, there's been a ton of progress in the rollup ecosystem in general. So I felt that it was time for a refresh. So I wrote this post called Rollup Economics 2.0. Essentially, like it looks at value flows for rollup, but in a broader ecosystem of mature rollups and mature rollups ecosystems. So I'll first go through the framework, and then I'll essentially try to like focus on like what are the economic drivers that determine like the current structure today of the rollup ecosystem, and then how it can evolve in the future. And I'll also give some open problems. Okay, just setting the stage. This may be familiar for the people that work directly on rollups, a little bit less for the other ones, but I want to introduce some common ground. So like what I'll call a rollup in this talk essentially is like there is a layer one, which you can think about as Ethereum or like some other layer. And there is a system of smart contracts on the layer one. And then there is an off-chain system, which is the L2, that lashes onto these smart contracts. So there is a sequencer that is responsible for posting data on L1 and sequencing transactions that arrive to the L2 system. Then there is a proposer that is posting the state root, computing and posting. And then there is a prover that is posting proofs. These proofs may be optional for optimistic rollup, where they're required for validity rollup. And of course, there is users that send transactions to the L2. And then one thing I want to say is that these roles are like functional roles. Like in maybe like early stage rollups, these are carried on by the same entity. But in more mature rollups, these may be like separated, decentralized, etc., the things that Yauchi was referring to. Okay, so this is another view of essentially the same diagram, but instead of the operations, I want to focus on the economic flows. So like the users send transaction, but they need to pay some L2 fees to the layer 2. And then the layer 2 incurs some operational costs for running the various functions, and then some data costs for posting data and other things to the data layer. And essentially, like in this basic model, this was the original post. You can define like the surplus of the L2 system as essentially the revenue they get from fees minus the operational and data cost. So this is a very simple world. Now, maybe just two words on the structure of fees that I will essentially like uncover later. So essentially there is fees that are divided by like the operational cost, the data cost, and then the congestion cost that is directly for the layer 2. And then there may be some potential MEV that the L2 system can extract. And this can be rebated to the user. It can be captured by the layer 2 itself, or it can be captured by other parties. So yeah, that was like the old framework, but since then, rollups have evolved a lot. So essentially, we need a new framework to really understand what's going on. And this is one I want to talk about mainly today. So essentially, like in the past months, we've seen that like these rollup ecosystems are growing, and essentially, like there is no central planner, right? It's like permissionless to like deploy rollups. So in a way, like there is an emergent market structure that is forming around different rollup ecosystems. And what I want to do is like go over the emergent topology. So in my post, I kind of like define different structure of that different ecosystems are kind of following. So I define Rollup cooperatives, Rollup federations, and then like the L3 ecosystems and all the services that are being built to facilitate the Rollup operations. So I'll go in detail into those. And then I also want to talk about the economic forces that are driving the evolution of the ecosystem to understand the present and maybe like gauge into the future. And so these are mainly related to profitability and then the liquidity and utility that are tightly related. Okay, so what are rollup cooperatives? So this is essentially like when two rollups come together to utilize a shared service, and the main goal there is to reduce cost. So it's a type of like economic integration between two rollups, essentially. Here I'm depicting rollup A, rollup B. If they were isolated, they would be doing all their operations their own and posting to L1. Here they use a shared service. So here you can think that the shared service is perhaps shared sequencing or like shared data posting. So essentially they use the same service to like more efficiently pack blobs in Ethereum or even shared proving. And this introduces another player, the service provider, that also has like some financial like balance to maintain. Okay, so the clicker is not working. Can you go to next slide? Yeah, so the other structure is what I call rollup federations. So here, essentially, like on top of integrating economically, like for shared services, these systems, they organize themselves around a shared token, right? So we see these emerge in many of the main ecosystems. So like you've probably heard talking about Optimism superchain. Arbitrum also like is experimenting with more chains, also like ZK Sync, Starknet, but essentially like on top of having like shared service and shared infrastructure, you also have a shared token, which essentially like you can use to regulate some ecosystems activities like allocating surpluses, making decisions, etc., etc. So like this introduces another flow, which now is like, okay, what is the monetary policy of this token? And it definitely like changes the economic properties and also the value of all these chains. Okay, so and then perhaps like the third structure is like all these layer threes. So essentially, this is like system that instead of latching on directly to the L1, they latch on to the L2, they settle on L2, and their data ultimately gets posted on layer 1. So like from an economic perspective, like these layer 3s are an additional source of revenue for the layer 2. The model is a bit different, as Yoshi was highlighting. These are often like potentially app chains, like chains that are interested in like lower cost and more programmability. So their revenue may not even come from fees. It could come from subscription or like other business models. Okay, so what are the economic forces that are driving like these structures? So the first one is like definitely liquidity is the most important one. Most of the applications that are deployed on these systems, they are economic or financial in nature, so they need liquidity, being it native or bridged. Why do you need liquidity? Because like it makes the markets of these applications more efficient. You may have more network effects. So the way that like different systems try to improve on like this direction is essentially by interoperability. So you are trying to reduce the friction of moving assets from other domains in order to get more bridged value into your domain. But this type of like more tighter technological and political integrations that I describe in Rollup Federation may also be very valuable, because like if you create an ecosystem, then you may get more native value, either because you can do more things on different chains that are sequenced atomically, or because essentially your token can start having more utility. Perhaps it can also start getting some monetary premium, so that gives more liquidity in the form of native value. But then the other important aspect, especially for L3s, is the utility, right? So utility does not just come from more liquidity, more efficient market, but it also comes from performance, configurability, and affordability, especially for products such as games, social media, like NFT-related products. So I think L3s and related services is a very interesting space that offer a different trade-off between like, okay, maybe the composability of like the L2 chain that latches onto L1 directly, and this type of performance and UX improvements. Okay. Finally, I want to talk about profitability, and I also want to talk about some related problems. We have done quite some research in this area. So the first interesting problem that is still quite open from my perspective is like on the revenue side, the revenue sharing schemes related to shared sequencing, right? So people are starting to build shared sequencing services, or at least like research like different design for this. And the promise is that these services allow to capture more MEV, because now you can atomically include transactions across multiple domains. But then the question is, how are these chains going to split the additional revenue that they're able to capture in this way? And also like, how can they capture it? How can they have like a decentralized system? These are also important questions. So the other area is, instead of on the revenue side, more on the cost side. So here, essentially, like the name of the game for like L2s and like other systems that need to post data to a secure layer is they want to do it in the most affordable way. So here there are two options. Either you choose a DA layer strategically, and essentially you may be trading off like security for much lower costs on average. The other one is like, if you already chose your DA layer, you can still do some optimization to like strategically like maybe delay posting like when the market is not surging in order to save on costs. And there is some research on this. We also have a very recent research on shared data posting between different rollups. So this is essentially like strategies that you can use to like more efficiently utilize blob space in Ethereum. And there is a few projects also building services on this. And then there is the whole area of efficient proving, and both like from a single domain perspective, like parallelization, aggregation of proofs, but then also shared proving potentially. And finally, there is the area of pricing. So I was talking initially about the L2 fees. So these L2 fees include both the fee that needs to be paid to the L1 or the A layer and the congestion fee for L2. So here, there is these L2s and L3s have less constraints than the layer one, so they can implement more efficient pricing. We have some research on a framework on how to do it, and this can be applied to like different L2s in different ways. And then the last problem is related to the fact that L2s have this kind of delay, structural delay between the time they get their revenue. So users are charged immediately when they send a transaction, and the time they incur their costs. Yeah, I'm concluding. So essentially, the idea is that you want to have like some systems to like manage the surplus or deficit that can be incurred by the fact that at the time you charge the user, you still don't know what the cost you're going to incur is. And you can do this with like some type of controller, and I know that Arbitrum has like some implementation of this. I don't know about other chains. Or you can do it economically by hedging, essentially with some block space derivatives. Thank you.